Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
For this problem, on the topic of force and motion, we are told that a person was shot over 3 Ferris wheels to land in the same height as an open end of the cannon from which he was shot. We are given the range of motion and told the distance inside the barrel at which the constant force acted. We are also given the launch angle and his mass. We want to calculate the magnitude of the force that propelled him within the cannon. So we'll first find the launch speed. So the launch speed V0 we know to be the square root of the acceleration due to gravity g times the range of motion r over sine of 2 times the launch angle theta. Since all of these values are given, we can put them in and find the initial speed with which he was launched. That's 9.8 meters per square second times the range of 69 meters over the sine of 2 times the launch angle, which is 53 degrees. And so calculating, we get V0, the initial speed, to be 26.52 meters per second. But obviously the speed is an angle of 53 degrees. So we need to break this up into x and y components. So the horizontal component of the initial speed, Vx, is equal to V0 times the cosine of theta, and this is 26.52 meters per second times the cosine of 53 degrees. This gives us the speed in the horizontal direction to be 15.96 meters per second. The speed in the y direction is equal to V0 times the sine of theta, which is 26.52 meters per second times the sine of 53 degrees, which gives us the y component of the initial velocity to be 21.18 meters per second. Now we also know that the acceleration is constant, and we can use the following equation to find the horizontal component of acceleration. So ax is equal to vx squared divided by 2x. So we know this equation for projectile motion, and we know these values. So this is 15.96 meters per second all squared divided by 2x, which is 2 into 5.2 meters, the distance that he is accelerated within the cannon, times the cosine of 53 degrees. That gives us the x component of that motion. This gives us the x component of acceleration to be 40.7 meters per square second. And from here, we can find the force component in this direction, Fx, by Newton's second law, is simply the mass of the man times his acceleration along the x direction. So this is 85 kg times the x component of acceleration, which is 40.7 meters per square second, which is 3,460 newtons. So that's the x component of the force acting on the man within the cannon. And we can do the same now in the y direction. So in the y direction, the acceleration ay is equal to vy squared over 2y, and this is 21.18 meters per second all squared divided by 2 times y, which is 2 times this y displacement within the cannon for 5.2 meters times the sine of 53 degrees. This gives us his y component of acceleration to be 54 meters per square second. And So we can now find the y component of the force that acts on the man in the cannon. So this is m times ay, but remember that his weight is also acting in the y direction, so that's plus mg. And so this is equal to 85 kg, the mass of the man, into 54 meters per square second plus 9.8 meters per square second. And this gives us the magnitude of the force in the y direction to be 5,424 newtons. And so we can find the magnitude of the force acting on the man in the cannon, F, to be the square root of the sum of squares of each component, fx squared plus fy squared. So this is the square root of 3,460 newtons squared plus 5,424 newtons all squared, which gives us the magnitude of the force acting on the man to be 6,434 newtons. So if we keep two significant figures, this is 6.4 times 10 to the power 3 newtons.